13.3, evaluate trig functions of any angle. Use the given point on the terminal side of angle theta in standard position to evaluate the 6 trig functions of theta. So this is a slightly different version of what we were doing the other day, where you had like a triangle, or it said, you know, like the sine of theta is equal to, and it gave us values, and we like made a triangle with that, and we solved all 6 trig functions. Remember that? Okay, well then you're going to be confused, and I would suggest you go back and study if y'all have already forgotten that. But we're going to be plotting points on a point on a graph, and then we're going to be finding all 6 trig functions of that. So 6 is the point, 5, negative 12. So this means that this is going to be down in quadrant 4. So it's positive x, negative y. So it goes down here. Okay, now all of these are going to have a side that touches the x-axis. If there is a side touching the y-axis, you have done something wrong. That's the most missed thing on this stuff. So my little triangle is going to look like this. So this is 5, this is negative 12, and I need to find the other side. So normally we call it R with trig stuff, but if you call it C, that's fine. So we've got 5, or this is the square root of 5 squared plus 12 squared. So it's the square root of 25, and 144 is 169.
Which is 13.
Which is 13. The hypotenuse value can never, ever, ever be negative. Okay, but your x and y value can be. The angle that I'm using is this angle that's touching the x-axis here and the origin. Okay, the one that's at the origin. I'm going to set up the 6 trig functions.
This is 13.
I'm not talking about this sheet.
All right, so sine of theta is opposite over hypotenuse. So that means this is negative 12 over 13. Cosine is adjacent over hypotenuse. This is 5 over 13. Tangent, opposite over adjacent. So that's negative 12 over 5. Cosecant, we just flip sine. So that's going to be negative 13 over 12. Secant, we flip cosine, so that's going to be 13 over 5. And then cotangent, we flip tangent, so it's going to be negative 5 over 12. So the important thing is making sure you can basically graph a point. It doesn't have to be exact. You don't need to like, you know, get out graph paper or anything. This is just like make sure you're putting it in the right quadrant. That's all you really have to do with this
So
one.
you don't have to number the graphic, the little dashes?
No. This is just like getting it in the right general vicinity.
Perfect.
All right, 8. Negative 6, 9. So where is this one going to be? Yep, quadrant 2, we've got a negative x, positive y. So it's over here. Again, it's touching the x-axis, not the y-axis. So x is negative 6, y is positive 9, and then I need to find my hypotenuse. So I'm going to say R is equal to the square root of 6 squared plus 9 squared. So it's the square root of 36 plus 81. Square root of 117. I don't know if I can take anything out of that. Let's find out. I can do 3 and 39. Yep, so I can take out a 3. So this is going to be 3 root 13. So remember, if we end up with the radical in the denominator, we're going to need to rationalize it. Based on what all these numbers are, I think I'm going to be doing a lot of reducing in these ones. So set up my 6 trig functions. All right, so what's sine of theta? Give it to me not reduced.
Do we
first.
always go from the angle towards the middle?
Yeah, always the one that's on the origin. 9 over 3 root 13. 3 goes into 9 3 times, so I would have 3 over the square root of 13, and then what would I end up with?
3 root 13 over 13.
Yep, 3 root 13 over 13. And again, I write it this way so that when I do cosecant, I can just flip it and not have to rationalize again. What would cosine be?
Negative 6 over 3 root 13.
Negative 6 over 3 root 13. 3 goes into 6 twice. So I'd have negative 2 root 13 over 13.
Over negative 6.
Yep. Which is the negative 3 over 2. I know I've said this before, but negative can go on the top, the bottom, and front, wherever. Cosecant, just flip the original value of sine, so square root of 13 over 3. Secant, flip cosine, so we've got negative square root of 13 over 2. And then cotangent, flip tangent, negative 2 over 3. Do we feel like we need to see another one of these ones? Okay. Big thing is make sure it touches the x-axis, because that's pretty much always where people go wrong. So just make sure you pay attention to that. All right, we have something called quadrantial angles, which are angles that fall on an axis. And so they want us to solve for the 6 trig functions of theta being whatever value that is. We're probably just going to do one of these. This is not something to be like overly worried about. But I want you to see it just because of that way you'll know what it is if it comes up again at any point. But this is a weird word.
Quadrantal.
It's a very hard word to say. So 12 is theta is 0 degrees. So essentially I'm finding the 6 trig functions of 0 degrees. So part of the reason for me writing it in the previous problems as r equals like the square root of essentially x squared plus y squared is because, I don't know if this was in your notes or not, but sine is y over r, cosine is x over r, and tangent is y over x. Like, but this is the way that a lot of it's written. So anyways, which means then that r squared is equal to x squared plus y squared as far as that goes. But that's essentially how I find those 6 trig functions. So this value for theta of 0 degrees is just right here on the axis. Now, they don't tell me absolutely anything else, but I know this is a value on my unit circle that we have marked, and this is 1, 0. Okay, like the point that it's going to is 1, 0. So, I need to find r, if you will. So, r is equal to the square root of 1 squared plus 0 squared. So r is 1. So x is 1, y is 0, r is 1. So we've got sine, we're going to set all these up. So I'm going to go ahead and set up all 6 and then we'll. All right, so sine of theta, and the reason that I set it up as that I wrote it this way, y over r and all of that, is because obviously it's kind of hard to look at this and figure out where the angle is and what's opposite and all of those things. So y over r, well, y is 0 and r is 1, so that would be 0 over 1, which is 0. Cosine is x over r, so that's 1 over 1, which is just 1. Tangent is y over x, so that is 0 over 1, which again is 0. Flip them, so cosecant is 1 over 0, which is undefined. Yep.
And then 1.
Yep. Secant is 1, cotangent 1 over 0, which is undefined. Now, you don't necessarily have to write the 0 over 1, 1 over 0, all of those things, but I just wrote them out so you can see them. So basically, anytime you're dealing with these, you're going to have 2 answers that are 1, 2 answers that are 0, and 2 answers that are undefined in all of these, depending on where it falls on the graph. So, any questions about those? Don't stress about those ones too much. Finding reference angles. So this is like essentially saying like find the like acute angle of the function. So 16, we have negative 100 degrees. These are not my favorite because there are formulas that go with this, but I think that a lot of times the formulas confuse people and it's easier just to visualize it. So I'm going to try to show it visually for you. So I'm going to set up a graph again. Okay. Now, I think about my unit circle. We talked about counting around in the positive direction yesterday, obviously with stuff and being able to figure out like approximately where something is. Well, I can also go in the negative direction. We had one of those early on in 13.2 with the matching ones that we did the other day.
Past the center line, right?
Yep, so negative 100. If I go down this way, let me see which way I want to draw this. If I go down this way, it's a little bit past 90 degrees, so it's somewhere in this general vicinity here. And I'm trying to find what this theta value is here. So reference angles are the angles that touch the x-axis. Now, negative angles do not work in the formulas that you had. Y'all had formulas in your notes, right? Okay.
I reckon.
You should have had something that was like theta prime is equal to like something minus 180, something plus 180. Yeah. Something 360 minus something, whatever. Okay. So I can't use negative angles with that, so I have to use the positive angle going around. So I need to figure out what value would be equivalent to this, aka what's my coterminal positive angle. 100 would be up here.
No.
So to find a coterminal angle, we add 360.
Oh, it's 260.
So 260 degrees would be my theta value. So
Yes, she is.
in quadrant 3, the formula for degrees is theta prime is equal to theta minus 180. So then I put 260 in here, subtract 180, and that is equal to 80 degrees. And that's my reference angle. Now, the reason that I say it might be easier for you to just look at it instead of trying to remember the formulas is that I can just look here and say, well, I know that in each quadrant there are 90 degrees. So if this is 10 past this, I need to take 10 off of 90. That value has to be 80. Okay? So if you're a formula person, you want to memorize formulas, you can do that. If you're more of a visual person, you can kind of use this method of kind of like eyeballing what it should be. Okay. 18. 320 degrees. Which quadrant is that going to be in?
4.
Quadrant 4. So it's going to be somewhere basically in here. Actually, probably need to go a little farther, but let's show it there. So that's approximately where it is. So theta starts here and goes all the way around. So that's my 320 degrees. And theta prime is my reference angle, which is this value right here.
And it's 360 minus theta.
Yep. So if you
Minus
can just
theta.
look at it, you can say, okay, well, I know I have 360. That's 320. So the theta prime's got to be 40. You can also use the formula, which is theta prime is equal to 360 minus theta, or 360 minus 320. So it is 40 degrees. Negative 5 pi over 6. So again, can't have negative angles. Obviously, I need to, well, I'm going to leave it in radians, but I need to add 2 pi, so I need a coterminal angle with this. So plus 12 pi over 6, because that would be the equivalent of 2 pi. So that would be 7 pi over 6. So then, now I'm going to use this. So where does this fall? What quadrant number?
In the third quadrant.
Third. Yep. So 7 pi over 6 is going to be somewhere down here.
It has 1. That's cool.
So this is my 7 pi over 6 value. I'm solving for theta prime, which is just this value between the axis and that angle. So the formula for this one is in quadrant 3, theta minus pi. So theta prime is equal to theta minus pi. Theta is 7 pi over 6. Minus, now I need a common denominator. So what would pi be with a common denominator?
6 pi over 6.
Yep, 6 pi over 6. So that means
It's just pi.
pi over 6.
Far.
All right, any questions on those ones? Okay, then our last step in this section says to evaluate the function without using a calculator. Good hint when you see that is it means you're using your unit circle. So, 24, we have the secant of 135 degrees. So obviously we already talked about, secant isn't on here directly, but I can look at cosine. So this is the same thing as 1 over the cosine of 135. So that's in quadrant 2.
Negative 2 over 2.
Yep, negative root 2 over 2. So this is 1 over negative root 2 over 2. Keep change flip. That gives me 2, or negative 2 over root 2. Rationalize it. Negative 2 root 2 over 2. 2's cancel. It's negative root 2.
Well, that's great.
Now, anytime that you see like a secant of a increment of pi over 4, it's always going to be root 2. Just if it's positive or negative is based on if cosine was positive or negative. But obviously mathematically you can find it, but if you're really good at memorizing stuff like that, then you might just memorize that secant of an increment of pi over 4 is always going to be root 2. 26. The sine of negative 150 degrees. So, 2 different ways that I can think about this. I can either say, I'm going to find the coterminal angle and I'm going to add 360 and look at it that way, because that would be equal to the same thing. Or I can just count backwards on my unit circle. So I'm going to do that method, but if you want to find coterminal, that works too. So, negative 150, so that means I come back here as negative 90, another 30, negative 120, another 30, which would put me over here as negative 150. So that's the same thing as the sine of 210, which is
7 pi over 6.
it's an x or a y value.
Yeah, I'm confused. Oh,
I'm not pointing at the answer, I was just pointing at the line.
1/2?
Yep, negative 1/2. $28. Cosine of 7 pi over 4.
That looks like. That does not look.
Root 2 over 2.
Bingo.
What'd you say?
Yeah, root 2 is.
Yep, root 2 over 2. And 30.
I really hope you don't have school.
Me too. Tangent of negative 3 pi over 4. All right, so you've got to count backwards. Okay, so negative 3 pi over 4. This is negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. Or you can find coterminal is the same thing as 5 pi over 4. So what's the cosine of that?
Negative 2.
Negative root 2 over 2.
I always say 2 over 2, but I know it's 2.
I know what you mean. Okay, any questions on that stuff?
I think.
Oh, it is. Well, I wasn't looking at the problem. That is the cosine. What is the tangent?
Oops.
I don't know why. I guess because we just done cosine. I was thinking cosine.
Me too.
Yeah. So what happens when I have to put the unit circle on top of my iPad and I can't see the problem anymore? Good catch. All right, questions about that? Okay, so problems for this section. We've got 3, 5, 7, 15, 17, 21, and then 25, 27, 29, and 31. So those last ones are just using your unit circle. So this is what I'm going to tell you. If we're not in school on Monday, your job is to do this as your virtual work. Okay? If we're in school on Monday, we're doing this in class on Monday.
Gotcha.
Okay? If we're also not in school on Tuesday, your job is to study your unit circle for at least 15 minutes. Okay? So, because next week we're going to have the unit circle practice. I think we said Friday. Is that right? Is that what we said? Let me say Thursday. Something like that. Yeah. If we're in school on Tuesday, you're going to have a quiz on 13.1 to 13.3 on Wednesday. Unit circle would just be extra credit at that point. Okay? If you get 100 on it, I could be persuaded to just also take that as your quiz grade, and then you wouldn't have to take it with everybody else at the end of the week.
Interesting.
So if that's a little incentive to study it early. You're going to be snowed in anyways. Might as well study math.
I hope I'm snowed in.
So, if things change, I'll put an update on Google Classroom. If we somehow get the snowmageddon of the century and we get 24 inches that they were, talking about a week ago, then we probably won't be at school next week.
Barely even gotten 1 inch in years.
But they told us that, or the most recent thing says like maybe 1 to 2. So, anyways,
2 inches.
I will update on Google Classroom if something changes, but basically you'll have Monday to work, whether it's here in person or virtually at home. But if we're not in school on Monday, whenever we come back, this stuff is due. If we're in school on Monday, it's just due Tuesday.
Days or restaurant?